Okay, members, now we are going to see curves without turning points, but please don't forget to subscribe. So we are almost now finishing the whole curve sketching. Now, curves without turning points, this is how we have them. Now, the question is, if y is this, show that y has no turning points, state the equation of asymptotes, and then sketch the curve. Now, if y has no turning points, of course, to get turning points, we go through the process of the y dx. Because this is the quotient, and expand this, you get this, and expand this, you get this. This is your u, this is your v. So the quotient rule, this is how it's said. Now, my v, when I put v here, then I differentiate u, I get x minus 5. Then my u, which is x minus 5, when I differentiate v, I get 2x plus 1. Then over the v squared, which is this. Then to simplify everything, we have to expand this and this to expand and get something like this. But you know that always at turning points, always our first derivative is 0. So when you equate this to 0, so that the order of this will be 0. When I cross multiply, this will vanish and remain in something like this. Divide by 6, you get this. And so that when I solve for x here, I'll be having a complex root because this will be negative 6. When you get the square root of this, this will be root 6. Then root of negative 1 is I. So that's why I'm having this. Because this curve sketching is for real values, and here we have unreal values which are complex, then we found that since x squared has no real values of x, then y has no turning points, and we get to mark that conclusion. Then set the equation of asymptotes. We start with the vertical. Vertical, we equate the numerator to 0. I mean the denominator to 0. We equate the denominator to 0 for vertical. So when I equate this to 0, I get 2. When I equate this to 0, I get 2. Now, because this power and this are the same, don't confuse it with partial fractions. For this one, we don't go long division here. This one said we only have slanting asymptotes if the power is strictly greater. The power and the numerator should be strictly greater than the power and the numerator. If they are equal, still we divide through by x to the highest power. So divide through by x squared without. And so when this 5, when x tends to infinity, 5 over infinity is 0. Then 6 over infinity is also 0. And so we have 1 minus 0 over 1 plus 0. 1 divided by 1, we get 1. So the horizontal asymptote is y equal to 1. Now, because we have our horizontal asymptote, we also check for the point of intersection between the curve and our horizontal asymptote. Why? By the way, if a curve has no turning points, even that curve is not going to have a region of restriction. So it means that curve is going to pass everywhere. Meaning, if we have a horizontal asymptote, there is a possibility of that curve intersecting that horizontal asymptote. That's why we look for always the intersection between the horizontal asymptote and y in the curve. So for them to intersect, of course, the y value should be the same. If I put here y, so that when I simplify, so that when I take this x cancels, when I take this side, I have 6x equaling 2. 6x equaling 2 now. When I take this side, I'll be having, this will give me 6x, this will give me 0. So now remember that this is going to be now 0. So it's that if I have 6x, now when I take this one, it's going to be cancelling. So say if it's 0, now our intercept is 0, 0, 1. So these 2 points are going to be meeting at 0, 1. So we always get that point of intersection between those two. Now, after doing that, so now this curve is going to intersect this line, asymptote, and this point. So here's the intercepts. When x is 0, when we put here 0, we have 0, 0, 0, 0, negative 6 over negative 6. We get a 1. That's a point 0, 1. When y is 0, when we put here 0, because multiply this will vanish. If we solve this, we get x equal to negative 1 and x equal to 6. There's a point, negative 1, 0, then 6, 0. The behavior, we first get the critical values by equating the numerator and denominator to 0. When you equate this and this to 0, you get negative 3, negative 1, 2, and 6. like the way I have them here. Then write them from big to small. From big to small. I mean from small to big. So you analyze where the smallest between this and the negative 1, then negative 1 and 2, then 2 and 6, then above the 6. So when you put in the values, this is what you are going to get. Now, we come and see how we are going to sketch that. Now, start by sketching our asymptotes. Our asymptotes are x equaling to 2, x equaling to 2 is here, I put it there. Then also x equaling to negative 2, I mean negative 3, which is here. Then horizontal is y equaling to 1. Anything different from a curve is probably using dotted lines. You name x equaling to 2, x equaling to negative 3, and y equaling to 1. So now, we say that now this curve is going to intersect our asymptote at 0, 1. At 0, 1, this is where they are going to intersect at 0, 1. So now, I think we have, now we come to the intercepts. We have 0, 1. 0, 1 which is there already. Then negative 1, 0. Negative 1, 0 is here. Then 6, 0. 6, 0 is also here. 6, 0 is there. Then I think that's all. Then we start plotting. So we say x, when x below negative values of below negative 3, the values of x, y is in the positive. So you see, below negative 3, this is below negative 3, y is in the positive. So you see, this is an asymptote and this is an asymptote. So for our y to be in the positive, it's going to be like this. Now between negative 3 and negative 1, it's in the negative. Between negative 3 and negative 1, this is the region. It's in the negative, mean that it's below the x-axis. We mean the y. If y, these are positive, these are negative y values, and above x are positive. So between negative 3 and negative 1, it's in the negative. So because there's an intercept there, it comes and raises that asymptote. Let me use now some green chalk, and asymptote like that. Then between negative 1 and 2, between negative 1 and 2, you start it's in the positive. So between negative 1 and 2, it's in the positive. So it's going to come like this. Because it doesn't intercept there, it's going to come like this. Between negative 1 and 2, it's in the positive. So it's going to be above x-axis and intercept there. Then it raises and asymptote like this. It can never touch a horizontal, but we say it can never touch, a curve can never touch a vertical asymptote. But we say it can touch a horizontal asymptote, but only once. That's why it's crossing. It can cross a horizontal asymptote, but only once, but it can never cross a vertical asymptote. Then between negative 2 and between 2 and 6, between 2 and 6, it's in the negative. Because it has an intercept there, it's going to be like this. It's in the negative. Then above 6, it's in the positive, above x-axis. Because this is an asymptote, can't cross it now again. It's going to be like that. Then we say y below negative 3. Y below negative 3, it's in the positive, asymptote. It's going to be like this. It raises the asymptote like that. So members, that's how we sketch that one. The curves without turning points. I think that there's no any turning points. The curve is everywhere. It's in this region, it's in this region, it's in this region. It's free to pass everywhere. I wish you the best.